Alright, so today we are going to finish out the Unit 9 notes packet, and you have learned so much this unit about the periodic table and atoms and elements on that periodic table, and we've moved into pure substances and different mixtures, and today we're going to focus more on when elements begin to bond and form compounds. So the first thing I want you to do is highlight the word pure substance. And a pure substance, we learned previously, is either an element, remember that's off the periodic table, or a compound. And a compound is made when elements are bonded together, and they're chemically bonded together. That's when they begin to share or give and take electrons. Okay, so let's make note of that. That means that they either share or give/take E negative. Okay, so that is when they bond. And then chemical formula uses chemical symbols like the symbol H for hydrogen, that's an H, and Na for sodium. And then subscripts, those are going to be the small little numbers. You can see one right here, the 2 for H2O, to identify the number and types of atoms in a compound. All right, so look at this first one, H2O. Here's our first example. So the first thing that we want to identify is what is it? And this, of course, I'm sure all of you know, is water. This is the chemical formula for water. So we see that we have H2O, and one thing that I want us to note is right here is an understood one. We wouldn't normally write this one here. It's understood, okay? So it's an understood one. You don't usually write. Okay, so from here on out, we're not going to have the one behind that. I'm sure you've never seen the formula for water with that one written there. So that is an understood one. You don't usually write that. But what that one means is that there is one oxygen and there are 2 hydrogens. But of course that one is understood because we wouldn't have written the symbol for O if there weren't at least one O there. Alright, so how many types of elements? How many types of elements do we have here? We have 2 types of elements. And to know that, you just simply count the capital letters that you see. 1, 2. We have 2 types of elements. We have hydrogens and we have oxygens. So how many atoms total do we have? Well, we have 2 hydrogens and we have 1 oxygen. And when we add that up, just like in math, we have 3 atoms total. And what that looks like in a molecular model formula is this. Okay? So when we look at this, would red be the oxygen or would red be the hydrogen? When we look at that. Based on what you know here, is red the hydrogen or is red the oxygen? So I know that I have only 1 oxygen, so this red is the oxygen. It bonds 2 times to the white hydrogens, and I have 2 hydrogens here. So this is what a molecule of water looks like. And these gray bonds right here represent, go back to here in your notes, electrons being shared between hydrogen and oxygen atoms. That's what these gray bonds represent. Hydrogen has 1 electron to share. Oxygen in its orbital needs 2 more. and that's why it will bond twice. So that's how all this bonding occurs, is either by the sharing or the giving and taking of electrons. So let's move over to this one. This one's going to be bigger. So C6H12O6, what is it? That is a type of sugar called glucose. That's the sugar that plants make during the process of photosynthesis. So how many types of elements are there? We just count the capital letters that we see. 1 capital letter, 2, and 3. So there's 3 types of elements: carbon, hydrogen, and oxygen. But how many atoms total are there? So that's where we have to go look at those subscripts. Does this have any understood ones in it? Nope. Everybody's got a subscript. So in this one, there are 6 carbon atoms. See the 6? There are 12 hydrogen atoms. There are 6 oxygen atoms. And we add that up. Do that without a calculator. You can handle it. When we add it up, I think 6 and 6 is 12, and 12 plus 12 is 24 atoms total. Okay? So if I were to make this molecular model, and it's a Friday afternoon and I'm tired and ready to go home, it would take 24 of these. It would take 24 of these to make this glucose molecule. We could certainly do it, and I might Monday when I get back to school. But right now, y'all just getting 2 waters out of me. Okay? So, the glucose has 24 atoms total. 3 elements, but 24 atoms. And that is what plants make during photosynthesis. All right, now here's where things get interesting. All right, look at this bottom one. We have water again, but it has a big number out in front. Okay, and you have big numbers like this show up in math. This big number out in front is called a coefficient. So, what is it? We kind of have already answered that previously, but we need to specify specifically what this is. This is 2 water molecules. Okay, 2 water molecules. That's what the big 2 out in front says. It says there's 2 of them. Remember, there's that understood 1 there. I'm not going to put the 1. It's understood. That's why we took the time to type out an O for oxygen. How many types of elements are there? There's only 2 types of elements, a hydrogen and an oxygen. How many atoms total are there? Now this is when it gets a little trickier, because right up here we had 3 atoms total in 1 molecule of water, but we're going to have to take the 3 atoms total and multiply it by 2, and that's where we're going to get a different answer. So what I like to do is say 2 times 2 is 4 hydrogens, and 2 times that understood 1 is 2 oxygens, and you add them up, and 4 plus 2 is 6. So there are 6 atoms total. Watch that one more time. The big coefficient out in front, it's like you have to distribute it like you would in math. 2 times 2 is 4 hydrogens, and 2, see how I did that? 2 times 1, that understood 1, I did wind up putting it there, didn't I? 2 times 1 is 2. So 4 hydrogens and 2 oxygens add together to make 6 atoms total. So in this, what is understood? That 1. What is the subscript? This little number 2. And who is the coefficient? that big number 2 out in front. So what is this going to look like? Well, instead of having 1 molecule of water, do you remember who the red was? That's your oxygen with 2 hydrogens bonded. Now we have 2. So do we really have 6 atoms total? 1, 2, 3, 4, 5, 6. Yes, we do. So now we're going to take and draw this picture right over here on our paper. Okay? We're going to try to draw it fairly realistic. So here's my hydrogen going to my bigger oxygen, going to my hydrogen, and I'm going to have 2 of those. Here's my hydrogen going to my bigger oxygen, going to my hydrogen. And let's take a minute and just add a little bit of color so that the oxygen and hydrogens don't look exactly the same. Now, I have added 2 examples to the bottom of this page, so I think it'd be a good idea for you to pause the video and add them to the bottom of your page as well. This first one is called potassium sulfate, and the first thing we're going to do is we are going to figure out how many different elements are in potassium sulfate, and then we're going to count the number of atoms total. You really want to pay attention here because as soon as you get done with this video, you're going to be doing this sheet by yourself. Okay? And you can see that I've picked 2 examples that are very similar to stuff that you're going to be seeing on here. So, potassium sulfate, how many different elements do we see? Well, we're going to look and count the capital letters. Those are our symbols. I've got potassium, I've got sulfur, and I've got oxygen. I've got 3 capital letters, so there's 3 different elements. But how many atoms total are there? Well, I have 2 potassiums. What's understood right here for sulfur is an understood 1. It would go right there. Okay, right there for the sulfur, an understood 1. And then how many oxygens do I have? Got 4. So I'm going to take and add those up. 2 plus 1 plus 4. And I add them up, and I'm going to get 3 plus 4 is 7. So my number of atoms total is 7. Now, hypothetically speaking, if there were a big old coefficient out in front, I could just, like, let's say 2. I could take that coefficient of 2, multiply it times 7, and my number of atoms would be 14. So next we have MgOH2. That chemical compound is called magnesium. OH is hydroxide. It's a strong base. This one's going to be a little different when we deal with the parentheses, but I'll get to that in a second. Let's first count our elements. So we count the capital letters. Mg is just 1 element, so I'm counting that 1 capital M, oxygen, and hydrogen. So I have 3 elements here. Now, how many atoms total are there? So there is an understood 1 here for magnesium. There's an understood 1 here for oxygen and an understood 1 here for the hydrogen. But they are in a parentheses with a 2 behind it. That means that this 2 goes there and this 2 goes there. Okay? So 2 times that understood 1 gives me 2 for the oxygen. 2 times that understood 1 gives me 2 for the hydrogen. So I've got that 1 magnesium, 2 oxygens, and 2 hydrogens. I add that up. 1 plus 2 plus 2 is going to give me 5. That's 5 atoms total for that compound. If I had a big old coefficient out in front, like if it was 2, MgOH2, then all I got to do is just take that 5, multiply it by 2, and my answer would be 10. So we've got a lot of practice coming on this. Your teacher will be around to help, but make sure that you paid real close attention right here. Okay?